All right, so we're moving on to plate tectonics. And in this PowerPoint, we're actually going to skip to slide 16 because that's where it starts talking about plate tectonics. I am leaving the other stuff in there because we've already talked about the layers of the Earth, and on Tuesday, you're going to be talking about the heat transfer, so you can refer to the PowerPoint if you need. Let me get to Okay, so the theory of plate tectonics. A scientist's understanding of mid-ocean ridges and magnetic reversal growth or grew, a theory was formed to explain how tectonic plates move. Earth's lithosphere was divided into tectonic plates that move around on the top of the asthenosphere. This occurs because of convection currents. Plate tectonics, a theory that the Earth's lithosphere is divided into tectonic plates that move around on top of the asthenosphere. A boundary is a place where tectonic plates touch. All tectonic plates share boundaries with other tectonic plates. There are three different types of boundaries, and earthquakes can occur at all three. So the first one is convergent boundaries. This is when two tectonic plates collide together um, when two tectonic plates collide together, a convergent boundary is formed. There are three types of convergent boundaries. So you have continental to continental, you have continental to oceanic, and then oceanic to oceanic boundaries. So here's just a picture of the two plates coming together. This is the ocean, this is the continent. So that would be the second type. Mountain building. Folded mountains, so formed at convergent boundaries where continents collide. This forms when rock layers are squeezed together and pushed upward. Example is the Appalachian Mountains when North America and Africa collided, and the Himalayas in Asia. The fault block mountains, which forms when tension causes large blocks of Earth's surface to drop down relative to other blocks. Examples the 10 tons in Wyoming. And then volcanic mountains, located at convergent boundaries when rock that is melted in subduction zone forms magma, which rises to the Earth's surface and erupts. Obviously, what a volcano does. All right, so here's the Appalachian Mountains. Here's the Tetons, and then the Hawaiian volcano. All right, the second type of boundaries is the divergent boundaries. This is when two tectonic plates separate. A divergent boundary is formed. So instead of coming together like the convergent boundaries where they're colliding together, divergent poles apart. New seafloor forms at a divergent boundary, most commonly a mid-ocean ridge. So this is where your surfaces are coming apart and magma is coming up. Seafloor spreading. Seafloor spreading is the process by which new oceanic lithosphere forms as magma rises toward the surface, then solidifies. The tectonic plates are moving away from each other, and the seafloor spreads apart and magma fills in the gaps. Older crusts get pushed away from the ocean ridge, where new crust is formed. And then mid-ocean ridges. These are underwater mountain chains that run through Earth's oceans. Mid-ocean ridges are where seafloor spreading takes place. And then this is technically the sea. And when the divergent boundary happens, they pull apart and then the magma comes up. And as it hits the water, it starts to cool and it forms a mountain. Transform boundaries. When two tectonic plates slide past each other horizontally, a transfer boundary is formed. So when this isn't going together, this isn't going apart, it's just sliding back and forth against each other. The San Andreas Fault in California is an example of a transform boundary. And again, sliding back and forth here. Causes of tectonic plate motion. Movement occurs because of changes in density in the asthenosphere. When rock gets heated, it becomes less dense and rises to the top of the asthenosphere. There, it cools off and becomes more dense, then it falls to the bottom. The cycle repeats itself, causing constant movement in the asthenosphere. This is known as convection currents. Remember, the tectonic plates are sitting on the asthenosphere. Where do earthquakes occur? Near edges of tectonic plates. As a result of the plate tectonic movement, faults exist in the Earth's crust. A fault is a break in the Earth's crust along which blocks of the crust lie relative to one another. Earthquakes occur along faults because of this sliding. How do earthquake waves travel? So seismic waves, and we've already learned about S waves and P waves way back at the beginning of the year. These are waves that travel through the earth. So body waves are seismic waves that travel through the Earth's interior. There are two types, S waves and P waves. And then you have surface waves, which are waves that travel along the Earth's surface. So body waves, obviously on the interior, surface is obviously on the top. P waves. A P wave is a seismic wave that causes particles of rock to move in a back and forth direction. They travel through solids, liquids, and gases. They're the fastest seismic wave, and they are also called primary waves because they are the first wave to affect the rock. S waves are a seismic wave that causes particles of rock to move in a side-to-side direction. Also called shear waves and are the second fastest seismic wave. They cannot travel through parts of the earth that are completely liquid. Also called secondary waves because they travel slower than P waves and arrive later. And then here's two examples, and these, again, should look familiar because we've already talked about these types of waves before. Surface waves. They move along Earth's surface. One type produces motion up and down and around. One type produces back and forth motion like S waves. It moves more slowly than the body waves and are more destructive. So the slower waves cause more problems. What is a volcano? It's an opening or crack in the Earth's surface where magma and gases come out. Where do volcanoes form? They form on the ocean, land, and hot spots. So this is form in the middle of a tectonic plate, edges of tectonic plates, subduction zone, and the rift zone, or the ring of fire. And this is between North America, which is here, and Asia, which is over here. So the ring of fire is in the ocean between these two. What causes volcanic eruptions? Convergent boundaries. So this is plates come together or collide. There's a subduction zone. One plate pushes under the other. And then divergent boundaries, plates pull apart, which is your rift zone, and make new crust. And that is it. Like I said, you can refer back to this PowerPoint for heat transfer when we talk about that on Wednesday. If you have any questions, let me know.